Hi guys, I'm going to try recording this one without a video so that you can really focus on the graphs, and I'm going to do some really horrible drawing on the screen with my mouse, so we'll see how that goes. We're still talking about functions, and we're still talking about finding their domain and range, but now we're going to focus on some other features of the graphs and how you can actually look at the picture and get this information instead of looking at the equation. So let's take a look at domain and range. By definition, the domain is the set of all x values that the function uses. I like the word uses better than attains. So you're thinking left to right horizontally. Is the entire x-axis being used, or are there some x values that are excluded from the set of values that can be used in this function? The range is the y values, so the set of all y values that the function attains. I like that better. You plug in the x, you get out or obtain the y, and that's bottom to top. So you want to start at negative infinity on the bottom and go all the way up and see, does this function cover the entire range of y values? So when you look at a piece of a function like this function has been cut off. It has a definite starting point and a definite stopping point. And so when we're asking you what's the domain of this function, you want to look as far to the left as the function goes. And as far left as this function goes is right here. That's as far to the left as it goes. So the x value that it uses that is the furthest to the left is -7. On the right side, the farthest to the right that it goes in terms of x is right there, which is +10. So we would say that the domain of this function is the set of numbers from -7 to 10. Now that's set notation, it's not a point. It's telling you the set of numbers from -7 to 10, and the reason there's brackets is because it actually includes those endpoints, -7 and +10. Now for the range, let me switch colors. We're looking at the lowest point. So in terms of the y-axis, the lowest this function gets is right there. I'm not very good with my mouse. So it looks like that's -4. And the highest it gets is right here. The highest it gets, it looks like, is at about 6. So we would say from lowest to highest, it goes from -4 up to 6. Let me erase that so you can actually see what's written there. Okay, so that's how you describe it. Again, set notation. Now there is another notation called interval or inequality notation. Inequality notation, you would say the x values between -7 and 10 using less than or equal to signs, and then the same for the y values between -4 and 6 using less than or equal to signs. You always have to have the lower number on the left and the higher number on the right, whether you're using set notation or inequality notation. Okay, so that's one example for you. Here's another one. It looks almost the same, except guess what? Over here on the right side of the graph, we have an arrow. That arrow tells me that this continues off of our screen. It goes down, 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 and it goes as far over to the right as you can possibly imagine. So when I'm trying to think about x values, yes, I see that the furthest to the left this graph goes is -8, but there is no limit on the right side. So we write that like this. We say from -8 with a bracket to +infinity with an open parentheses, because that just goes on and on forever. Same thing in terms of y. I can see that the lowest y value it seems like it's going to be right here, but guess what? That arrow means that it keeps on going down to -infinity. So you can't really say that the lowest point is -5 or 6. You're going to have to say -infinity is the lowest point, and then the highest point it looks like for this one, if I could draw straight, I can't. Looks like it's about right there, so it looks like it's at 5. So I would say that the range is from -infinity, that's the lowest value, to the highest value, which is +5. And again, set notation, or if you want to, you can use inequality notation. When it's not between two numbers, you can say just like x is greater than -8 and y is less than 5. So you can give an extreme value and then just go from there. All right, so that's how you define the domain and range when you're looking at the picture of a graph. There are some functions that have a domain of all real numbers and a range of all real numbers. If it just goes on and on in both directions, then that's what it is. Okay, now this one's a little bit different because it has an open circle on one end. That means that the domain and range are going to have an open parentheses in their description. So let's take a look at it. The domain is the x values. How far left does it go? It goes to there. How far right does it go? It goes to there. So between those 2 points, from -4 to 5, bracket on the -4 because it's a closed circle, parentheses on the 5 because it's an open circle. The range, high point and low point. Here's the high point, here's the low point. So I would say it goes from -4 to positive, oops, sorry, -8, I'm talking about the y values, to +8. My mistake on that. Okay, what if the graph continued forever? You can see where we've drawn the red arrows. Well, then it's going to have a domain of all real numbers because it goes to the left and to the right ever so slightly in both directions. So you're going to say from -infinity to 5, and then here's a new symbol. This means that you're going to join two sets together. That's called the union notation. So we're going to combine the set from -infinity to 5 with 5 to infinity. The reason we had to do that is because of this hole. The hole means that there's one value, and I'm going to circle it in yellow here, there's one value that is not used or obtained on this graph, and that's 5, 0. So we're going to eliminate 5 from the domain, and we're going to eliminate 0. Oops, let me go back. We're going to eliminate 0 from the range. I guess I can't go back when I'm recording. Okay, now the next thing we're going to talk to you about is not the domain and range, but a different concept, the idea of whether a function is increasing or decreasing. Increasing very simply means it's going up as you go from left to right. As x moves from left to right is y going from bottom to top, or decreasing would be as x moves from left to right is y going from top to bottom. So that would be decreasing. So it's probably pretty easy for you to see. Increasing, if we move, always go from left to right on the graph. As we move here, you can see that this one is increasing everywhere. It's just going up, up, up. If it has a little curve in it, that's okay. Now the other one that we have, if you look at the second graph, you can see as you move from left to right, tracing it with my purple pen here, I'm decreasing, then I'm staying steady, and then I'm increasing. So we have different regions of increase and decrease. On the left, it's increasing everywhere for all real numbers. You can say that with that R symbol, or you can say from -infinity to +infinity. The second one is increasing only from an x value of negative or +3 and up. So that's where we have it increasing. The x value of 3, it's increasing in that final region. It's decreasing in the first region, which is from -infinity to -2, and it's constant in between there. And that's what we call that, constant. So you've got increasing and decreasing, or constant. Okay, now the next slide is going to talk about another way to think about graphs. Sometimes we don't care whether they're going up or going down. We care about whether they're positive or negative, meaning are they above the axis or are they below the axis, right? Positive values in terms of y are places where the graph is above the axis. Negative is where it's below. So if negative is red, we can see that this graph is negative down here. And it looks like it crosses right here. So there it changes. It's still increasing everywhere, but while it's increasing, it's in the negative region first, and then it moves into the positive region. So the positive region would be here, everything that's here. All right, so how would we say that? It's positive from -3 to infinity, that's the yellow, and it's negative from -infinity to 3. So we're dividing it up into positive and negative regions. Okay, again, this one we talked about it being increasing or decreasing. I'm looking at the second one here, but I don't care about that anymore. I care about where it's below the axis, which is this region right here. That's where it's negative. And then it's positive on the other side. So we would say it's positive from -infinity until -5. And then all of a sudden it goes down below the axis. So now it's negative. And then it hits here and it becomes positive again. So that's the 7 to +infinity. Negative in that middle region from -5 to 7. So again, different concept. Increasing and decreasing is different than where something is positive or negative. And then finally, we talk about where are the absolute minimums and maximums, like the highest point it ever gets to, the lowest point it ever gets to, and where are its relative maximums and minimums. So if you look at this one, you can see the highest point this obtains is right here, the vertex of this parabola. So we would call that an absolute maximum. Over here, this is also an absolute maximum, but over here we have a smaller peak. That's what we call a relative maximum. It's the highest point in that area relative to the other points, but it's not the absolute highest point, okay? So it's a peak, but not the highest peak. And then same thing for minimums, okay? This would be a relative minimum, but it's not the lowest point on the graph because look over here. You see that these arrows are saying that this is going to go down forever. So there is no absolute minimum for this second function. So you actually give the ordered pair where it hits these points because it's not a region, it's a place. It's an actual location on the graph. So take a look at this first one. The absolute maximum, they're saying, occurs at the point -1,6, and it has no absolute minimum because of the arrows going down. For the second one, it has an absolute maximum at that first peak. It has an absolute minimum nowhere because the arrows go down forever. It has a relative maximum at 3,2, that's that second little peak, and then it has a relative minimum here in the center that I've circled in purple. Okay, so what you're going to be asked to do in your homework is take one graph and give me all of that stuff. Give me the domain and the range. Give me where it's increasing and decreasing. Give me where it's positive and negative. Where it's relative maximums and minimums if it has them, and absolute maximums and minimums if it has them. So let's look at this one. This looks like a polynomial function, and this unit is going to include polynomials. The domain, if you look at the x-axis, think about what x values are being used. The arrow shows me that it's continuing to the left and to the right with no boundaries. So the domain is all real numbers. The range is the highest and lowest y values that it gets to. So because it has arrows pointing upward, there is no top value that it gets to, but it does have a low point. That low point right there tells me that the range of values is only from about, I don't know, I'm trying to see where that is. It looks like it's about -7.5 and above. So yeah, -7.5 to positive infinity are the only kind of y values you're going to get out. You're never going to get any y values down here. Okay, now let's think about where it's increasing. Increasing is where the graph is moving upward from left to right. So always go from left to right, because if you go backwards, then it's going to be, your answers are going to be backwards. So increasing. I see, I'm tracing with yellow here, that this is going up here, and then I also see an area where it's going up over there. The other parts of the graph are going downward, so those are called decreasing areas. So increasing in that first yellow region between x equals -6, it's increasing from here until here. So between those two yellow hash marks. And then it's increasing again from 2.8, which is about right here, to positive infinity, the second yellow marking. Decreasing. It's decreasing in the lower region, so from -infinity to -6. Remember, I'm telling you what region of the x-axis includes decreasing function values. And then also in the center, we have a decreasing area from -2 to 2.8. So that's this region right in here, where the graph is going downward. This was our other decreasing region right there. Okay, now if I erase all that, that was the increasing and decreasing stuff. Now let's think about where is it positive and negative. That's asking where it's above the axis and where it's below the axis. So literally think about drawing a line through the middle here. Here's a chunk of graph that's below the axis. That's negative. So here's another chunk of graph that's below the axis. Those two are negative. Anything above the graph, those are positive regions. So putting it into set notation, the first piece of the graph on the far left side from -infinity to -8.2 is above the graph. That's up here. Let me change colors here. That's up here, okay? That's a positive piece of the graph. Then it switches to a negative piece of the graph. Then it switches to a positive piece of the graph. Then a negative piece of the graph, and then a positive. So these are switching back and forth from one to the other. Positive to negative to positive to negative to positive. Okay, now relative maximums and minimums. Those are the highest points in an area. Not the absolute highest and lowest points, but the highest points in an area. So let's see, the relative minimum, the lowest point in a particular region. Let's do the absolute minimum first. The lowest this graph gets is right here. That's going to be its absolute minimum. But there's going to be no absolute maximum because the arrows go up forever and ever. This little peak right here would be called a relative maximum. It's not the highest point on the graph, but in that region it's the highest point. And then this little piece over here, this little valley, is going to be a regional or a relative minimum. So our relative minimum, there it is, that was the last thing I circled. Our relative maximum, that's this one right here, this little peak. The absolute minimum is down here, that's the lowest point the graph ever gets to. And the absolute maximum, there's none. Okay, you're going to see some homework problems like this. Please copy down the problems. You don't have to draw the graphs, but you definitely need to show your work if there is work to be shown. All right, thanks guys. See you later.